Hello, my name is Garrett Andrews, and this is my week 14 presentation about ecosystems, in particular marine ecosystems, and even more specifically the coral reef ecosystem that we got to choose very beautiful organisms from in order to do this. For my primary producer from a graphic, I picked Seagrass because we all know what seaweed is and there's some similarities between them. So that's why I picked it as my primary producer. And above I added the picture of, as you will later know, is a meadow of seagrass. And I think it's very beautiful. I wouldn't want to touch it when I'm swimming, but I wouldn't mind looking at it. It's autotrophic. It gets its energy from the sun, as many things do, but it doesn't consume any other organisms. It's a bean fig because it resides exclusively on the seafloor, and it's also a plankton because it's unable to move itself. It relies on tides and currents and waves in order to move. And I picked a fun fact for all these, and for a fun fact of seagrass is that Florida has over 2.5 million acres of seagrass meadows, which one day if I'm ever in Florida, I would love to see it because I think I'd like to scuba dive and see it, even though we're not too deep, but yeah, I think it'd be pretty cool and beautiful to see. For my primary consumer, I picked the queen conch because I don't know, the name really sparked my interest, and I found a very beautiful picture of one. This cute little eye, and it's a heterotroph. It gets its energy from consuming. It eats the seagrass right here. It is both pelagic and bean fig. I looked this up online, and from my knowledge, it was kind of confusing, but in the first half of its life, it will be living exclusively on the sea floor, which is where we get this from. But after, it will start swimming around and not be exclusive to the sea floor. It'll be pelagic. And it's a nekton because unlike the seagrass, it is able to move on its own and it doesn't require waves or currents or tides to make it move. And a fun fact for queen conch, it's conches produce a very pretty pearl, which grown up in movies and shows and pictures and videos, I always heard that they produced a pearl, but I never knew it was actually true, but it is actually true. And this is a two-part fun fact, even though the parts have nothing to do with each other, but for the second one, it's with age, its shell will get thicker, which it's like a tree. And as you can see, this one, I don't know, relatively, because I'm not an expert, but it looks pretty thick to me, so this one is probably a decent age. And for my intermediate consumer, I picked the Caribbean lobster. As you've seen in the latest slide, I had to pick it because I want to incorporate some fun into this. It is a heterotroph. It will eat the queen conch, and it'll get energy from doing that. It is a benthic. It says it lives exclusively on the sea floor. Doesn't swim. It's a nekton because, as you can see, it has many plentiful legs to move itself around and walk, and yeah, it doesn't require currents, waves, anything like that to move it. And for a fun fact, the eggs of a Caribbean lobster are bright orange. And I don't know if you're on TikTok, but my TikToks, I don't know why I see lobster videos, and most lobsters that I see have like black eggs. But this is bright orange, which are really cool and unique to see. And for my top predator, it's the blacktip reef shark. When I initially saw the graphic, I just assumed it was a great white, but it is not. You can see it's a blacktip. It's a heterotroph because it gets its energy. Because it'll eat these lobsters. It really stands no chance for this. I picked this picture because this Roman living its own life. Really beautiful. It does not exclusively live on the ocean floor. It swims around in the water. Is a nekton. They do not require waves or anything of the matter to move them. And growing up, I always said that sharks always had to keep swimming or they die. I think I got that from Shark Boy and Lava Girl. I don't know how true that is, but yeah, the definition of a nekton. And for a fun fact, instead of producing eggs, like a lot of fish, you know, it's a they produce up to 10 pups each year, which I would imagine a baby shark would be very, very cute. And for my decomposer, I picked the Detrius, which I think, I'm not positive, was the only option we had on the graphic. And here's a picture I could find of it. There wasn't many options, but it's a heterotroph because when this dies, or this dies, or this dies, it will consume the remains of dead animals and other organic waste, which is very important to keep the ecosystem going. It does, believe it or not, live exclusively on the ocean floor, and it is a plankton because it cannot move on its own. It requires waves and currents and tides to move it. And yes, these are the things that I picked from the graphic to make my, in this case, food chain, but we know it's a food web. Producer, consumer, consumer number 2, top consumer, and decomposer. And this is my food web illustration. I really wanted to draw it, but I don't have any crayons or anything. If it was just not colorful, it wouldn't have been fun, and we want to keep it fun. So it starts off up here with the sun. The seagrass absorbs the sun's energy, allowing it to grow and thrive to be a good primary producer. As you can see from this pic, I picked it because it's very green, very healthy, very thriving. And the next step in the food web is the seagrass is then eaten by the queen conch, which is the primary consumer in this specific ecosystem. So this conch will be eating this grass. And I picked this picture because while I think most animals look cute, I still think it looks cute, but this one looks pretty scary in my opinion. And as I said later in the slide, you'll see I picked it because I wanted to make a SpongeBob reference, even though I know he's a crab. I couldn't lay the lobster, but I wanted Mr. Krabs. But the next relationship, queen conch is then eaten by the Caribbean lobster, which shows the relationship between the primary producer and the intermediate primary consumer and the intermediate consumer. Maybe Mr. Krabs. And for this picture of the blacktip reef shark, I picked the most intimidating one I could find. It does look pretty scary. And this relationship is The Caribbean lobster is when eaten by the blacktip reef shark, which demonstrates the relationship between the intermediate consumer and the top predator. And for this relationship, after the top predator hopefully lives a long life, it is then consumed by the decomposer after it dies, which hopefully lives a long life. Very beautiful animals. And here's my decomposer down here. The abiotic factors, I looked it up, there's 5 major ones, which include temperature, sunlight, water, salt, and waves. But temperature is important, as you will also see on the next slide, because reefs cannot live if it's too hot or too cold. It needs to be an in-between. Sunlight is also very important, as without it, there would be no energy for at least my primary producer that I picked to live and thrive to feed the other ones. So without sunlight, the whole ecosystem will go down. It is, I'd say, probably the most important factor. And water, self-explanatory, you need water in this ecosystem. And salt, also very important. The salinity levels have to be just right, because obviously if there's no salt in the water, these organisms wouldn't be able to survive or live. So the salinity level has to be just right in order for this ecosystem to live. And waves are also important, as I will describe in the next slide. But yes, all 5 of these are actually really major in the survival of the ecosystem. And what aspects impact the coral reef ecosystem? And I picked this picture because it was the most vibrant, colorful, beautiful one, most beautiful one I could find. And yeah, blue water, beautiful colors. For physical, like I said in the last slide, I explained it more on this slide, but waves can bring in nutrients which help reefs thrive and grow and reproduce, and they can carry away harmful chemicals which could hurt them potentially. Which is, yeah, waves are important. For biological, fish will hide in the reefs, which is a pretty well known fact. And I didn't know this, but they will protect coastal areas by reducing the power of waves. I never knew that, but it's really cool that they protect us. They protect our land, and we gotta protect them any way possible. We gotta protect the environment. And for chemical, coral reefs cannot. Oh yeah, this picks up on the last slide too a little bit. But they cannot survive in any temperature under 64 degrees Fahrenheit, which I believe translates to 18 degrees Celsius. So they gotta be the right temp in order for the reefs to survive. Because if it's too cold, they're gonna die. If it's too hot, they're gonna die. We need to keep it how it is. And for geological, marine sediments can smother the corals and interfere with their ability to grow and reproduce, which is what we don't want. And according to the thing I looked up when I was researching, is by smothering them, they can bleach them, which is obviously not good for them. It kills them, and it will take away all these beautiful colors, and we really don't want that. We want them to be thriving and healthy and doing what they can to help the oceans. And I think that's the end. Thank you so much for watching. It was very interesting to learn about, and I'm happy I got to learn about it. Thank you.